will begin shortly. Meantime, I would like to explain or say the session's schedule. Today, we'll be having a keynote address on what controls tribological interaction by Dr. Satish Vasu Kailas. And as the slot 2 of today, from 3 p.m. to 5 p.m., we have the introduction to tribology by Dr. Jayashree Bijpe. Tomorrow, slot 1 is from 9:30 a.m. to 11:30 a.m. The topic will be role of microtextures in controlling wear and friction, which will be handled by Dr. Sukhjit Bhaumik. The slot 2 is 11:30 a.m. to 1:30 p.m., which is the introduction to tribology, its impact on society, which will be handled by Dr. Satish C. Sharma. And the slot 3 is from 3 p.m. to 5 p.m. The topic is some fundamental aspects of tribology, which will be handled by Dr. A.P. Harsha. The third day, which is Wednesday, slot 1 is from 9:30 a.m. to 11:30 a.m. The title of the session is Introduction to Bioluminescent Formulation, which is handled by Dr. Amit Aravind. Slot 2 is from 11:30 a.m. to 1:30 p.m., which is concept of fluid film lubrication, which is handled by Dr. Satish C. Sharma. And slot 3 is from 2 p.m. to 4 p.m., which is lubrication and lubricants on an overview, which will be handled by Dr. Rani S. On Thursday, which is the 28th of August, the first slot is from 9:30 a.m. to 11:30 a.m. The topic is experimental methods in tribology, which is handled by Dr. Rajkumar P. Slot 2 is from 11:30 a.m. to 1:30 p.m., which is the introduction to nanolubricants, which is handled by Dr. Manu V. Totakat. Slot 3 is from 2 p.m. to 4 p.m. The title is Some Emerging Hard and Wear Resistant Coating Process, which is handled by Dr. Tijo D. On the 5th day, that is Friday, which is the 21st of August, slot 1 is from 9:30 a.m. to 11:30 a.m. The topic is Tribology of TI6A14V and Electrical Discharge Coating EDC Technology, which is handled by Engineer Jibin T. Philip. Slot 2 is from 11:30 a.m. to 1:30 p.m. which the topic is Evaluation of Mechanical Properties of Materials Using Surface Measurements, which is handled by Dr. M.D. Matthew. Slot 3 is from 3 p.m. to 5 p.m. Human Values and SOPs, the Science of Rubbing is the topic, and which is handled by Dr. Muruganandan P. The 6th day, which is the final day, that is Saturday, 22nd of August, slot 1 is from 9:30 a.m. to 11:30 a.m. The topic is Modification of Engineering Surface for Tribological Applications, handled by Dr. Om Prakash Khatri. Slot 2, which is 11:30 a.m. to 1:30 p.m. The topic is Importance of Surface Coordination during tests and simulation tribological interaction, handled by Dr. Aniruddin P. And slot 3, which is 2 p.m. to 4 p.m., we'll be having the online assessment test and validatory functions. Our inauguration will begin shortly. Thank you.
And personalized mentoring bring out the best in you. Saintgits Group of Institutions, the unmatched ecosystem for academic excellence. Saintgits College of Engineering, the only unaided engineering college with 7 NBA accredited courses in Kerala. Saintgits Institute of Management, Saintgits College of Applied Sciences. Excellent coaching and personalized mentoring bring out the best in you. Saintgits Library showcases the gravity with which it drives the learning process. Unleash the power of learning by doing. Hands-on laboratory experiences are critical to the learning process. Saintgits is equipped with the best-in-class laboratories which expose the students to the most advanced instruments, machines, and technology. Saintgits Center for Innovation and Entrepreneurship fosters innovative and creative entrepreneurial activities in the campus. Our primary focus, engineering by doing. Saintgits students' pioneering state-level achievements include 5 consecutive years of participation in the Baja competitions organized by SAE USA. The first ever concrete canoe of Kerala was built by our students of the Department of Civil Engineering for the competition organized by the American Society of Civil Engineers. Our students of the Department of Electrical and Electronics Engineering built the first ever electric all-terrain vehicle from Kerala to qualify for track racing in terrain vehicle motorsports. Preferred recruitment destination for many prestigious companies like Infosys Limited, Amazon, IBM, TCS, MRF, and Indian Navy. The most beautiful moments in one's life are born on campus. At Saintgits, life beyond academics is full of possibilities. The popular fests of Saintgits, Nakshatra, Synthesis, and Gits Blitz reflect the spirit of the youth. Hostel facilities for all. A home away from home. Chase your dreams. Pursue your passion and define yourself at Saintgits. We at Saintgits believe that greatness is already within you. We will help you bring it out because we are equipped to do so and we genuinely care about you.
Good morning, ladies and gentlemen. I welcome you all to the 6-day AICTE sponsored online short-term training program series on the recent advances in tribology and surface engineering, which is conducted by the Saintgits College of Engineering. We will begin our integration shortly. Within 2 or 3 minutes, we will begin our integration ceremony. Thank you for your patience. Good morning, all. We'll begin our inauguration very shortly. We are extremely sorry for the 5 minutes delay. Thank you for your patience. As you all know, we have some of the best speakers here for our training program. This is an AICTE sponsored online short-term training program series on recent advances in tribology and surface engineering, which is conducted by the Department of Mechanical Engineering of Saintgits College of Engineering. As you all know, this online short-term training program is sponsored by AICTE.
Right. Chakor, shall we start?
Yes, sir. Yes, sir.
Okay. Am I audible? Okay. Good morning, ladies and gentlemen. Welcome to the 6-day AICTE-sponsored short-term training program series on recent advances in tribology and surface engineering conducted by the Department of Mechanical Engineering of Saintgits College of Engineering. First of all, before beginning this session, to seek the blessings of Almighty Lord, let's have a silent prayer. Now, to present the welcome address, I invite Professor Dr. Jacob T. Vergas, Head of the Department of Mechanical Engineering.
Hello, good morning. It seems I'm audible. Greetings from the Department of Mechanical Engineering at Saintgits, Kerala State, and Jacob Verghese from the desk of the head Department of Mechanical Engineering. Officially, I am assigned with the great responsibility to welcome everyone to the series of AICTE-sponsored short-term training program on recent advances in tribology and surface engineering. I directly step to my responsibility now. First of all, at Saintgits, we have the most respectable person, Sri Thomas T. Johnson. He is the director of the Saintgits group of institutions. With great respect, I cordially welcome you to this inaugural program of AICTE-sponsored STTP, organized by the Department of Mechanical Engineering. The Executive Chairman of Saintgits Group of Institutions, Engineer Unus George, he is the standing support to everyone at Saintgits. With great pleasure, I extend my cordial welcome to you. We have with us another important person for this day, Colonel B. Venkat. He is the Director, Faculty Development Cell at AICTE, New Delhi. Sir, it's a great honor to have you here today. With great pleasure, I cordially welcome you to this inaugural program. Now, I feel extremely honored to welcome the prime person of the day, our chief guest, who is about to inaugurate this AICTE-sponsored program. It is none other than Dr. Satish V. Kailas, Professor at the Department of Mechanical Engineering, IISc, Bangalore. With great pleasure, I welcome you to this program. Here, at this moment, we recognize the presence of our principal, Dr. Kunipal C., our vice principal, Dr. Koshi Varghese, the management member, Dr. Vinny Punis, the Dean Research, Dr. M.T. Matthew, and the Registrar, Dr. Muruganantham. We cordially welcome you all to this inaugural program. Before I conclude, there are 3 more groups to be welcomed. We have nearly 550 participants from all over the country. We recognize the presence of a handful of participants from foreign universities as well. These participants are our stimulus today. I extend a warm welcome to all the participants. Our colleagues from various departments at Saintgits, and in particular, all the faculty and staff from the Department of Mechanical Engineering are cordially welcomed to this program. At the end, the coordinators of this program, Dr. Jason Cherian-Isaac, Professor, Mechanical Engineering Department, and Dr. Chapo Pranakoshi, Associate Professor of Mechanical Engineering Department, are cordially welcomed to this program. With this, I conclude my part. Stay connected throughout the program. Stay safe and healthy at the place where you all are. Thank you very much. And from the desk of the Head Department of Mechanical Engineering. Thank you very much.
Thank you, sir. Now, to give us a briefing on this short-term training program, I call upon Dr. Chako Pranakoshi, Department of Mechanical Engineering, who is the coordinator for the same.
Director, Saintgits Group of Institutions, Engineer Punus George, Executive Chairman, Saintgits Group of Institutions, Chief Guest, Dr. Satish V. Kailas, Professor, Indian Institute of Science, Bangalore, Guest of Honor, Colonel B. Venkat, Director, Faculty Development Cell, All India Council for Technical Education, New Delhi, Dr. Joseph Kunjpal, Principal, Saintgits College of Engineering, Dr. M.T. Matthew, Dean Research, Saintgits College of Engineering, Dr. Jacob T. Varghese, Head, Department of Mechanical Engineering, Dr. Jason Cherian-Isaac, Professor, Department of Mechanical Engineering, STTP Coordinator, distinguished professors, ladies and gentlemen, a very warm welcome to Saintgits College of Engineering. It is my honor and pleasure to address you regarding the AICTE-sponsored online short-term training program on recent advances in tribology and surface engineering series 1 of 4 with specific topic Introduction to Tribology and Surface Engineering, scheduled on 17 to 22 August 2020. The current wave of globalization is taking place precisely because it is part of the beginning of the era of knowledge-based society and economy, in which knowledge is the only meaningful factor of production and other factors are secondary and can be obtained easily provided there is knowledge. My present duty is to give you a brief introduction about the STTP series on recent advances in tribology and surface engineering. First of all, as already informed by the head of the department, we are glad to inform you that we have received more than 550 applications across the globe for the STTP. The STTP series consists of 4 schedules in the month of August, September, October, and November 2020. They are divided based on the content of the main topic of the STTP as mentioned below. The series 1 is Introduction to Tribology and Surface Engineering, scheduled during this week. Series 2, Tribology of Machine Components and Applied Tribology, scheduled during 3rd week of September. Series 3, Introduction to Special Topics like Nanotribology, Biotribology, and Space Tribology, during 2nd week of October. And Series 4, Surface Characterization and Treatments in Tribology, during 4th week of November. Sequence of friction, wear, and lubrication is referred to as tribology. The term tribology is derived from the Greek word tribos, meaning rubbing or attrition, and logi, meaning knowledge. So the literal translation would be the science of rubbing. Jost report published in 1966 coined the word tribology, which was defined as the science and technology of interacting surfaces in relative motion and of related subjects and practices. Importance of tribology for sustainable reliability cannot be overemphasized. It is reported that loss due to improper understanding and application of tribology is over 1.5% of GDP of the developed countries like USA. We can well imagine the state of affairs in our country, where awareness about importance, understanding, and application of tribology is rather low. Tribological failures are responsible for over 40% of breakdowns in industry. Therefore, engineers working in the field need to have a thorough understanding of tribological practices so that proactive measures can be implemented in place of traditional corrective and breakdown maintenance practices. The history of tribology is as old as history of mankind, the main driving force being the facilitation of daily activities by reducing friction. The first man-made bearings were identified date back in the Middle Stone Age with the use of stone door sockets, bearing for wheeled vehicles, and bearings for stone potter's wheel. The Greeks originally applied tribology to understand the motion of large stones across the land. Tribology is multidisciplinary in nature and includes mechanical engineering, material science with research into wear resistance, surface technology with surface topography analysis and coatings, and the chemistry of lubricants and additives. The relatively younger disciplines of tribology are biotribology, which includes wear, friction, and the lubrication of total joint replacement; nanotribology, where friction and wear are studied on microbar nanoscales; and space tribology. The aim of this program is to provide a platform to academicians, practicing engineers, and R&D professionals for sharing their knowledge and experience in this field. The program is intended to provide an international platform for interaction between renowned tribologists of the globe and the participants, comprising of teaching professionals, research and PG scholars, and practicing engineers from industry. Also, this program intends to identify the areas where current research is being focused and to promote its viability. The core course contents includes basics of tribology with analysis of friction, wear, and lubrication, basics of fluid film lubrication and hydrodynamic bearings, lubricants and its chemistry, rheology of lubricating greases, tribology of machine components such as rolling element bearings, gears, and lubrication tribology of machine elements, applied tribology, special topics like nanotribology, biotribology, space tribology, and tribology at extreme environments. It is with this background that the Department of Mechanical Engineering, Saintgits College of Engineering, Kottayam, is organizing the STTP series on recent advances in tribology and surface engineering during August, September, October, and November 2020 at our prestigious institution to reinforce the need of continued education in tribology and interdisciplinary science and technology of friction, wear, and lubrication. Lastly, I, on behalf of Saintgits College of Engineering, wish all the participants a fruitful week to nurture your career for spreading the word tribology across the globe. Thank you very much indeed.
Thank you, sir. Now, with immense happiness, I invite Engineer Punus George, Executive Chairman of Saintgits Group of Institutions, to deliver the presidential address, as our Director, Sri Thomas T. Jones, sir, is preoccupied with some emergency.
Respected Chief Guest, Professor Dr. Satish V. Kailas sir, Colonel Venkat sir, esteemed faculty members of Saintgits as well as of other institutions in India as well as abroad, other esteemed delegates, students, a very warm welcome and greetings to you from Saintgits group of institutions. We are extremely thankful to the distinguished chief guest as well as the chief guest, the guest from AICTE for their valuable time in attending this program. Saintgits, from its inception in 2001, has been on the forefront in bringing latest subjects in technology, which have wide ramifications in increasing productivity as well as growth. Tribology is one of such subjects, as already explained or detailed by Professor Chako Pranokoshi. This is most important in the face of a growing country like India, wherein we have a lot of energy requirement, and energy always saved is energy produced. And due to tribological insufficiency, that is the application insufficiency, there are a lot of loss, which is always there in any manufacturing or any other industry. And due to production loss, due to breakdown, this is also very important aspect to consider in industries. Mechanical engineers, as the leaders in industrial arena, has to be very careful in choosing the tribological contents or choosing the factors which will reduce the losses in the process which they are taking care of. And now in the modern world, there is a lot of importance for tribology, especially now since we are in the era of robotics and automation. In the days when we were graduating engineers, only bearings and moving parts in an engine, that is all was the concern of tribology, or to the layman's concern, layman like me. But now we realize that automation as an inbuilt requirement of tribology and tribological applications. This is very much present in the microelectronic mechanical systems or nano electromechanical systems, which will be definitely be a part of our day-to-day life, which can be seen very conspicuously in our day-to-day life. So I would like to congratulate the Department of Mechanical Engineering under the leadership of Professor Jacob for bringing out such an important aspect as a thought process among the delegates present here. I would like to wish all the delegates a fruitful STTP and all success for the program. Thank you.
Thank you, sir, for your kind words. Now the time has come for the inauguration and inaugural address. For that, we have Professor Dr. Satish V. Kailas, who is a professor in the Department of Mechanical Engineering of IISc Bangalore. Dr. Satish V. Kailas has graduated his BTech from Government Engineering College, Thrissur in 1987 and later did his Master's and PhD from Indian Institute of Science in 1989 and 1994 respectively. He started his professional and research career as a research associate at IISc Bangalore during the period 1994 to 96. He moved to United States of America as a guest researcher at National Institute of Standards and Technology, Maryland in 1996 to 97. He later came back to India and joined the Department of Mechanical Engineering of IISc Bangalore as an assistant professor in 1997. He was promoted to associate professor in 2003 and later as professor in 2009. He has several recognitions to his credit, including INAE Young Engineer Award. He has published more than 200 peer-reviewed journal papers and even authored several book chapters in the field of tribology. He is an editorial member of reputed journals like ASME Journal of Tribology, Weir Journal of Material Science, Metallurgical Transactions, and so on. Further, he is a reviewer of several reputed international peer-reviewed journal papers. Dr. Satish has even authored a book titled Liberation Through Education. So, sir, I invite you to do the honors.
Thank you. Thank you, Grishma. I think that's your name, right? Because many
Yes,
times
sir.
your online identity and what you are different.
Thank you, sir.
So thank you, Grishma. And I should thank Chaco for giving me this opportunity to talk. Thanks, Chaco. Chaco, I hope you're doing well there.
Yes, sir. Yes, sir. Sure, sir.
Very good. Nobody's troubling you.
Yeah, nobody is troubling me. Sir. I'm fine.
Okay, good. So I would also thank the principal, Punus George, and head of the department, Jacob. So between the three of them, Chaco, Punus, and Jacob, I think they have talked about whole thing about tribology. They have covered most of the aspects. Now one wonders what to cover after their speech. Anyway, you people have to bear with me for a few minutes now, and then maybe for a couple of hours after this. I was once asked by my friend from Belarus, Mistin, he says, you know how important tribology is? So I just looked at him, I didn't tell anything. He says, when the Prince of Wales asked him this question, they had some 50th anniversary of tribology, coined the word tribology in the Buckingham Palace. So when the Prince asked him how important is tribology, so he told, tribology encompasses the whole life. He says, we are born because of friction, we live because of lubrication, and we die because of wear. I'm sorry, my phone is ringing. We die because of wear. So it encompasses everything, and that it actually tells you the whole gamut of tribology, where from biotribology to eco-friendly tribology to various things where we have to work very hard on what you call getting this Just excuse me. I'm in a meeting. Can call me. This is what happens when you get stuck with administration. They would persist to call you irrespective of whether you don't lift the phone or not. And it encompasses the whole thing. And like Chaco told, it costs about 1.5% of the GDP. Tribology, on the face of it, looks very complicated. But if you go understanding it systematically, it makes it easy. In fact, if you understand tribology, you understand a lot of fundamental aspects in other subjects too, because it is a highly multidisciplinary field. You have biology, you have physics, you have a large amount of chemistry, and you have design going into it. And that is one important thing. A tribological design, any machine designed without tribology in mind is going to be a headache. So tribology based design is an extremely critical thing. Now, the world is running and moving towards trying to make things that are very, very smooth and nice. People are talking of even ultra low friction materials, so much so that one of the speakers in the last year's conference at IICTE told that if they achieve what they claim to have achieved, or they are heading out to achieve, for building the pyramids, you did not need have these hundreds of people pulling the blocks. You could have a small child push the block into position. Unfortunately, reaching that stage in a mega scale is very difficult. But I do hope after the end of this particular workshop that is being conducted and the series that Chaco is planning over 3 to 4 months, we will be able to see extremely learned speakers giving talks on various aspects of tribology, and all of you would get enamored by this field of tribology and jump into this field to do work on this. So with these few words, I would thank again the organizers for calling me and asking me to inaugurate this workshop. So I do wish the participants have good time over here, and I also wish the organizers to have a very smooth conference. Because conducting conferences online is challenging, especially bandwidth. So God knows when my internet might conk off, but it happens, please bear, it is beyond my control. And I do wish a very good conference. Thank you very much. Reshma?
Thank you, sir. Thanks a lot. Now, to give us a formal note, I call forward Professor Dr. Joseph Kunyupol C., the Principal of Saintgits College of Engineering. Sir, you're muted. Just a minute.
Yes.
Can you hear me now?
Yes, sir. Yes, sir. Completely. Yes, sir.
Okay, sorry. Respected Director of the College and President of the Function, Sri Punyus George, Chief Guest of the Program, Professor Sadhishwi Kailas, IIC Bangalore, Dean Research, Dr. M.D. Matthew, Head of Department Mechanical Engineering, Dr. Jacob Varghese, Coordinator of the FDP, Dr. Chaco Panakoshi, Professor Mechanical Engineering, Saintgits Engineering College, Dr. Jason Jerian Isaac, resource persons, faculty members, and other delegates from various institutes. Very fine good morning to all of you. the chief guest, the coordinator, as well as the previous speakers has already given a brief understanding about the surface engineering and tribology. So what I wish to tell, I am purposefully omitting because there is no meaning in repeating the things which has been already mentioned. Anyhow, if a surface engineering can be regarded as an independent property or independent characteristic, tribology is a dependent characteristics, because surface engineering can stand on its own, whereas tribology is related between the components which is having mating parts together. And as far as mechanical engineers are concerned, the main requirement is to produce components that is to be available at a minimum cost, and again it should satisfy various characteristics like maximum efficiency, extended life period, less weight, and again the component should be as small as possible. And in this aspect, both the surface engineering and tribology has a very significant role to play. And in order to satisfy this engineering concern and to produce these equipments and to satisfying these requirements, a major research, a thorough study into the tribological aspects as well as surface engineering aspects has to be well studied. So both the tribology and surface engineering is occupying a paramount position in day-to-day affairs, and that is a topic very much relevant to mechanical engineers. That may be the reason why there is an overwhelming response when various participants from all over the nation to attend this short-term training program. At the outset, let me extend our thanks to the AICTE for funding this program, sponsoring the program by the Mechanical Engineering Department. And again, let me congratulate the coordinator, HOD, and all the Mechanical Engineering Department for selecting a topic which is relevant to mechanical engineers. And I wish the program more success. Thank you.
Thank you, sir. Now, I invite Professor Dr. M.D. Matthew, Dean, Research, Saintgits College of Engineering, to deliver an address.
Good morning to all of you. Can you hear me, please?
Yes, sir. Yes, sir. You're audible.
Okay. Thank you so much. Distinguished panel on the inaugural program, Engineer Punnus George, Executive Chairman of Saintgits Group of Institutions, Professor Satish V. Kailas, Professor at Department of Mechanical Engineering in IISc Bangalore and a doyen of tribology in India, Colonel B. Venkat, Director of Faculty Development Cell at AICTE, our dear Principal, Professor Joseph Kunjupal, and Dr. Jacob T. Varghese, Head Mechanical Engineering Department, Dr. Chako Puno Porshi, one of the two coordinators, Professor Jason Cherian Isaac, also the coordinator of this very important program. At the outset, I would like to congratulate the Mechanical Engineering Department, the head and the coordinators for organizing this very important series of short-term training program. In fact, it has been organized as 4 series. That itself shows the depth and width of this topic, as also its importance. Tribology, as all of you all know, is a very important subject because it deals with friction. And when we talk about friction, there is a medium in which the friction happens. The friction leads to wear, and the medium is there, and the quality of the medium decides the extent of lubrication as well as the extent of wear. So if we need to reduce wear, we have to think about the material, and also we need to think about the lubricating material. So a lot of studies are being carried out to modify the properties of the lubricant by introducing nanomaterials and things like that. The other way of controlling this wear behavior is to modify the surface. So surface engineering and tribology are interrelated. You cannot see them in isolation. And for the same reason, it's a multidisciplinary subject. It deals with mechanical engineering, it deals with metallurgical engineering, chemical engineering, and a lot of aspects of physics, chemistry, etc. And it's very important not only for the industry, it's a very complex subject. So engineers and scientists have a lot of interest in that. It's also important for the industry. A lot of economics angle to this because the a component which has a very good wear resistance means it will have a much longer lifetime. And there are the environmental aspects of it also because a component which undergoes wear will never be, optimally efficient, which means it will use more of energy. And any method of consuming more energy means we are talking of carbon footprint and global warming and things like that. So there's a chain of, branches of science and engineering which are linked to this broad field of tribology and surface engineering. And that is precisely, I think, the reason why we have a very good response, a lot of people. And if you look at the titles of the various talks during this 4-part series, you will get a feel of how complex this subject is. And as I said, it's interdisciplinary. Surface engineering and tribology are closely related. And I myself had an opportunity to work on this subject during my research career, where, as you know, in a nuclear reactor, a power reactor which produces electricity, for example, 500 megawatt electricity, is producing steadily the amount of power. And this power is generated as a result of millions and billions of nuclear fission reactions which happen at the same instant. Now, how do you control this? We have what is called a boron. If you want to control this rate of nuclear fission, then it is controlled by using boron. So in a reactor, for safety purpose, there is what is known as a control rod. This control rod is made of boron. It's an enriched isotope version of boron that is used. As you know, boron is a poison of neutrons. So if these neutrons come in contact with the boron, it will absorb neutrons. So obviously the number of nuclear fission reactions comes down. So obviously the amount of electricity that is produced is come down. So by adjusting the level of this boron control rod, you can increase the amount of electricity produced or decrease the amount of electricity produced in a normal operation. Now, there are situations where you have to scram the reactor. Suddenly, out of safety reasons, you have to shut down the reactor in as quickly as possible condition. So you have to drop this control rod. And this control rod moves within a sheath of stainless steel. So when it moves through this sheath of stainless steel, when you are dropping it for safety reasons, it has to move effortlessly, without friction, without wear, in the shortest period of time. So the kind of research that I had to do was to give a coating to this boron containing steel on the surface so that its wear resistance is very good. But then what happens is that it is moving in a stainless steel tube, and when it is static, it undergoes seizing. That means it will self-welding. So if you want to drop it, it may not move also. So you need to have a coating which is having very good wear resistance and which will not allow this self-welding or seizing. So that at any time you want to drop the control rod, it will slide very fast. So we developed a special coating made of stellite. Stellite is a cobalt-based tungsten-containing alloy. So we deposited it on this control rod. And then we found that when we did a lot of studies, we found there are a lot of micro cracks in this coating. So we had to do very detailed research and understand the metallurgical behavior and the microstructure of the material in order to develop this coating of stellite without any cracks, because cracks are not desirable. We are talking of safety. So I just wanted to illustrate one example where, how critical this wear and the tribology is. So I will not take more of your time. I'm very happy that the department is organized. I would like, especially as I mentioned, congratulate the organizers, the head of the department, and the coordinators, and all the members of the department. And I'm sure that the participants will enjoy, and they will get enriched, and they will get a new direction in the area of tribology and surface engineering. Thank you very much.
Thank you, sir. Today, Colonel B. Venkat, Director of Faculty Development Cell of AICTE, New Delhi, was supposed to be here for this inauguration, but due to some emergency meeting at AICTE, Sir was not able to attend this. So he has conveyed his best wishes for our STTP. Now, to propose the vote of thanks, I invite Professor Dr. Jason Cherian Isaac, the Professor of Department of Mechanical Engineering and the coordinator of this short-term training program.
Good morning. As we are nearing the end of the inaugural function, there are many people to thank for. And we received the funding from AICTE. And then further, they gave us the permission for online facilitating the STTP. And this resulted in a 4-part series, and each spanning 6 days. So in his absence, I want to thank Colonel B. Venkat, the Director of the Faculty Development Cell of AICTE, for all his help. At this time, I would like to thank our Executive Chairman, Punus George, for his presidential address, and our Director, Dr. Thomas T. John, for all his encouragement. Thank you, Dr. Satish Kailas, Professor at IIC, for his inaugural address. And you have sparked a renewed interest in us, and thank you for your inaugural address. We would like to express our thanks to to our principal, Joseph Kunjapal, for his support, and Dr. M.D. Matthew, who is a Dean Research, for his enthusiasm. I would like to express my thanks to all the members of the Mechanical Engineering Department who have volunteered under the leadership of Dr. Jacob T. Verghese, our HOD. And I want to thank Dr. Chako Pranav Koshi, the coordinator, for working tirelessly for the success of this program. And a big thanks to all the experts who accepted our invitation as resource persons for this STTP. And we would like to thank all the participants who have registered from far and wide for this online STTP. So we are all looking forward to an exciting 6 days of learning. Thank you.
Thank you, sir. With this, we have come to the end of our inaugural ceremony. So with immense happiness, it's me, Reshma, Susan, Reggie, leaving you for the day. Thank you. Happy learning.
Thank you, Greshma.
Welcome, sir.
We have come to the end of our inaugural schedule, and now we have a special lecture from Professor Satish V. Kailas, who will be addressing us with the topic, what controls tribological interaction. He's a professor from Indian Institute of Science, Bangalore, and he has been mentor to many of us who has done PhD as well as masters in tribology. Over to you, sir. Sir, your mic is off.
Yeah.
Yeah, yes.
How many of you have heard of chacogens? How many of you have heard halogens? Chacogens, halogens, you know, right? Chlorine, bromine, they are called halogens. So chacogens is very less known in this series. Where oxygen, sulfur, selenium, tellurium, all of them are chacogens, but it is written as CaHalCO, but it is pronounced as chacogen. So Chaco, you are famous, okay?
Thank you, sir. Thank you.
It is named after you.
Thank you, sir. It's my first information.
Even I came to know of it a few months back, or maybe a year back. So what I will do today is give you an idea of what tribology is about. Are you able to see my screen?
Yes, sir. Yes, sir.
So it is basically a talk that I give in most places. Keep updating it or changing it. But what I find is that the amount of changes required is actually minimal and fundamentals remain fundamentals. And I would be approaching it in a slightly different way than what is there in textbooks. Okay, so the first I would not start with tribology. The question I would ask the audience is, what should we be pursuing? Is it tribology? Or is it, you can unmute your mics, especially if you don't have a disturbance at the back, I have no problem, so that it can be a more interactive session. Otherwise, what happens is when I crack a joke or tell something, I wouldn't know what you are either laughing or you are sleeping in the back. So the audience can unmute their mics and be more proactive in this seminar. So, yeah, but if there's somebody who's causing a disturbance, then or some disturbance in your back, please mute it. So, what should we be pursuing? I think after hearing Punus, George, and others, one is very clear that tribology is important. So, you might wonder that we will pursue tribology. So, Chaco, what should you be pursuing?
Sir,
Huh?
I will be carrying out some research work in the area, sir.
Okay, so all of us should be pursuing happiness. Not whatever we are doing, we should have happiness in what we are doing. Otherwise, there's no point. The question is, if you want happiness for an hour, what do? Take a nice nap. The world is close to you. If you want happiness for a day, go for a picnic. If you want happiness for a week, go on a vacation. All of this is now ruled out because, except nap, because of the present corona situation. So if you want happiness for a month, you can get married. This you can still do. In fact, I tell my friends and students who want to get married now, because the number of invitees are very less. You can't have more than 50, I think, in Kerala. And so that makes the expenses very low in the marriages. Rest of the money you can use it for some better. If you want happiness for a year, what do? Inherit wealth. And after 1 year, you will realize all this means nothing. So if you want happiness for a lifetime, what to do? You want happiness for a lifetime, learn to love what you do. This is all from the internet, but I like this particular thing. If you want happiness for a lifetime, learn to love what you do. And this is different, completely different from learn to do what you love. Many times we are pushed into situations which are beyond our control, including the present scenario, where we are simply not able to move out to the house, and a lot of curtailed activity on the. I think somebody is drawing on my screen. Is it you, Chaco? I don't know who's drawing on my screen, but this is completely different from learn to do what. So whatever situation you are stuck in, you must learn to love that. Otherwise, or whatever thing you're doing, you must learn to love that. And that is what this should be sustainability. And when I say sustainability, even tribological sustainability becomes key in this. Okay, but I will not be talking about sustainability in this particular talk. So when you take any part in this moving part in this world, you will definitely have some friction and wear. And each part has to overcome some friction to do the work or to transmit work. Without that, things will no mechanism in this world will work, including your knee joints to your the valve, heart valve, to various valves in the body that control the blood flow. You can imagine whatever it is. So if you take a bearing, for example, you need to have low friction and wear. The requirement is completely different from that of a brake, where you need to have high friction and low wear. And if you are taking walking, for example, you are putting a shoe and walking, you need to have medium friction and low wear. You should not have high friction, because then walking becomes that much more difficult to walk. And if you have very low friction, you will slip and fall. And obviously, you won't have low wear because you don't want to keep changing your shoes or slippers. Next is car, where you have a requirement of variable friction. Car, when I'm talking of the tire wheel interaction. While it is rolling, you need the friction to be low, but when it starts to skid, your friction should shoot up substantially. In fact, car is a very tire interaction, road interaction is interesting because it's always incipient sliding that takes place between the car tire and the road. But it never goes into real sliding unless you slam your brakes. Even that doesn't happen these days because of the braking systems that is there. And so why this braking system has come into place is because if you have a sliding friction, the temperature goes up, and temperature goes up, it is observed that the friction between the tire and the road reduces. So, but you have a peak friction in the incipient sliding velocity, sliding moment. And so what they would control is to avoid complete sliding, but have continuous incipient sliding to have the highest braking. And then comes IC engines, you have low friction and low wear. Now, almost every moving part has to overcome some friction to do it. And every part has an optimal level of friction and wear. In the world basically has been trying to, for example, in IC engines go down to lower and lower and lower frictions, or in bearings to go to lower and lower and lower frictions. But my contention here is how low is important. Do we go to a friction of 0.1? Do we go to a friction of 0.01? Do we have to go to a friction of 0.001? People are talking of 0.00001. Do we need to go there? Now, if you make a calculation, the energy loss or energy gain you get, let's say, from reducing friction from 0.6 to 0.1, 0.1 to 0.01, and 0.01 to 0.001 is progressively getting lower and lower as non-linear as the system is, and it's also progressively getting more expensive and more what they call extremely careful engineering that would be required to reduce this, to reach a level of this kind of friction. So in one of the meetings that I attended, I told, pushing for lower and lower friction, it sounds nice, but it's hardly important. Because in any case, you might have a bearing that has got extremely low friction, extremely low wear. Maybe it will last you